Since ancient times, humankind has always been obsessed with gigantic monsters, creatures beyond imagination. But what if their secrets were not in the future, but hidden in stone tens of millions of years ago? Those living time machines, those gigantic fossilized vertebrae, silent yet powerful enough to awaken an entire lost world where fear and wonder coexisted. What allowed these giant snakes to reach sizes beyond our imagination? This journey will take you from the deserts of Kutch, India, to the swamps of Colombia to discover the 5 largest snakes in history, kings that rewrote the limits of size and strength on Earth. When fear and wonder awaken, snakes, with their mysterious appearance and silent hunting ability, have always been among the creatures that both terrify humans and spark endless curiosity. Yet the snakes that exist on Earth today, though large enough to make a strong impression, are but small shadows compared to the true monsters that once ruled the planet. Their gigantic size challenges every notion, raising a dramatic question. If these prehistoric giant snakes still lived, would humans have any chance of survival? To seek the answer to this question, paleontologists had to turn back time, following clues left behind tens of millions of years ago. Fossilized bones hidden in stone are not only proof of the existence of these great predators, but also a doorway revealing a lost world where the rules of size and strength were completely rewritten. This report will explore those fossils, beginning with a groundbreaking discovery in India, to open the list of the largest snakes in history, challenging even our imagination. The Prologue from a shocking discovery. In 2005, at the Panandhro lignite mine in the Kutch region of Gujarat, Western India, a groundbreaking scientific discovery took place, completely changing our perception of the maximum size a snake could reach. Researchers from the Indian Institute of Technology, Roorkee, excavated a series of 27 exceptionally well-preserved, fossilized vertebrae belonging to a previously unknown snake species. This snake was named Vasuki indicus, inspired by the sacred serpent god in Hindu mythology and the name of the country where it was found. This discovery was particularly significant because the number of preserved vertebrae allowed scientists to carry out detailed analyses and produce reliable estimates of the creature's size. Based on predictive regression equations, the length of Vasuki indicus was estimated to reach between 10.9 and 15.2 meters, with a weight of more than 1 ton. These numbers immediately placed Vasuki among the fiercest rivals of the famous giant snake Titanoboa, and in some of the highest estimates, it was even thought to be longer. This proves that there were snakes that not only challenged, but may even have surpassed the record of the so-called king of snakes. The emergence of Vasuki indicus on the list of giant snakes was not simply a race about size. This discovery provided valuable clues about the ancient ecosystem of India, a region then isolated from Asia. The fossils were found in a gray shale formation dating to about 47 million years ago in the Eocene epoch, showing that this snake lived in a warm, swampy tropical forest, an environment capable of supporting large animals. With a thick cylindrical body, Vasuki was likely a slow, ambush predator, relying on its tremendous constricting power to subdue prey, much like modern pythons. The Vasuki fossils opened the door to a journey of exploration into giant reptiles, laying the foundation for a deeper understanding of how extraordinary size shaped life on Earth. Top 5 Prehistoric Giant Snakes. The pinnacle of size and strength. Let us begin the journey across space and time to uncover the greatest predators that once ruled this planet. Number 5. Gigantophis garstini, the Trailblazer of the Eocene. Gigantophis garstini was one of the first giant snakes known to science, paving the way for the study of prehistoric reptiles. Its fossils, discovered in Fayum, Egypt, included part of the spine and a fragment of jawbone. This snake lived around 40 million years ago, during the Eocene. Before Titanoboa was described in 2009, Gigantophis had long been considered the largest snake ever recorded in history. Early estimates based on rough comparisons of its vertebrae with those of today's largest snakes suggested it could reach lengths of 9.3 to 10.7 meters. However, later estimates were revised down to about 6.9 meters when scientists applied more comprehensive biometric equations. This change illustrates an important reality in paleontology. Estimating the size of a creature from only a few bones is a major challenge and must be constantly updated as new data and methodologies emerge. These adjustments do not reduce the significance of Gigantophis. Rather, they highlight the progress of science and the differences between estimation methods, from simple comparisons to more comprehensive measurements. Gigantophis remains one of the largest snakes of the Madtsoidae family and an important milestone in research history. The fossils of Gigantophis were found alongside fossils of marine vertebrates, such as whales, sirenians, sea turtles, and crocodiles. This suggests it was an aquatic or semi-aquatic snake capable of ambushing prey in water. It may have hunted large reptiles, including ancient crocodiles. Number 4. The genus Madtsoia, a lineage of strange endurance. The genus Madtsoia, a key member of the Madtsoidae family, represents one of the longest living snake lineages in Earth's history, with a presence spanning nearly 100 million years, from the Cretaceous to the Eocene. This remarkable longevity allowed them to survive the mass extinction event at the end of the Cretaceous, the KPG event, when non-avian dinosaurs disappeared. One of the most striking features of Madtsoia is its wide geographic distribution across the southern continents. Fossils have been found in Argentina, Brazil, Spain, India, Niger, and Madagascar. This distribution is geological evidence that they evolved and dispersed when the supercontinent Gondwanaland still existed, before the continents drifted apart. Their ability to survive and spread across different regions over such a long geological period demonstrates their extraordinary adaptability and resilience. Scientists suggest that, as cold-blooded animals, Madtsoia may have survived the extinction event by maintaining life with less food over longer periods than warm-blooded animals. Although Madtsoia fossils are often incomplete, consisting only of scattered vertebrae, they still provide enough clues to identify it as a constrictor predator, similar to modern pythons. However, analyses of jaw structure show more primitive features, with a limited ability to open the jaws wide to swallow large prey compared to modern snakes. This suggests Madtsoia followed an independent evolutionary path, not achieving the same jaw adaptations as modern snakes, yet successful enough to remain an effective predator for millions of years. Number 3. Palaeophis colossaeus, the death god of shallow seas. Not all giant prehistoric snakes lived on land. Some evolved to adapt to marine environments, and among them, Palaeophis colossaeus is a prime example. This giant sea snake lived during the Eocene, hunting in shallow seas and coastal estuaries. With an estimated length of 8.1 to 12.3 meters, it was one of the largest sea snakes ever known, capable of hunting massive ocean prey such as large fish, mollusks, and perhaps even smaller marine reptiles. Its adaptation to aquatic life was more complex than often imagined. Studies show its vertebrae were not flattened, as some speculated, but only slightly modified for aquatic life. This adaptation is reflected in microstructure and histology, such as high bone density and dense vascular networks within the vertebrae, similar to modern sea snakes. High bone density helped them control buoyancy, while the dense blood vessel network indicated high metabolic and growth rates, necessary to achieve such extraordinary size. The existence of a semi-aquatic giant snake like Palaeophis demonstrates the incredible ecological diversity of ancient snakes and their adaptability to different environments. Instead of competing with giant reptiles on land, Palaeophis exploited the rich resources of coastal waters. The morphological differences between Palaeophis and modern sea snakes testify to parallel evolutionary paths toward aquatic adaptation, showing that not all aquatic species share the same skeletal structure. Number 2. Vasuki indicus, the Indian executioner. As introduced earlier, Vasuki indicus deserves a high place on this list thanks to its extraordinary size. Discovered in India, this snake lived about 47 million years ago. The comparison between Vasuki and Titanoboa is one of the most fascinating topics in modern Paleontology. Although Vasuki's fossils show its vertebrae were smaller than Titanoboa's, length estimates produced a surprising result. Based on regression equations, Vasuki's length was estimated between 10.9 and 15.2 meters, while Titanoboa was estimated at 12.8 to 14.3 meters. This shows that a body with smaller vertebrae could still correspond to an overall longer body, depending on the number of vertebrae and body structure. Specifically, Vasuki is described as having a thick, cylindrical body and was likely a slow ambush predator, terrestrial or semi-aquatic, similar to today's giant pythons. Comparison table: Vasuki versus Titanoboa. Vasuki indicus proves that the evolutionary history of snakes still holds many mysteries waiting to be uncovered, and new discoveries can completely overturn what we once thought we knew. Number 1. Titanoboa cerrejonensis, the true king of the Paleocene. At the top of the list, and still the most famous giant snake, is Titanoboa cerrejonensis. This snake ruled the vast swamp forests of South America about 58 to 60 million years ago, in the Paleocene, a time shortly after the extinction of the dinosaurs. Its fossils were discovered at the Cerrejón coal mine in Colombia by a research team from the Smithsonian Tropical Research Institute in the University of Florida. The discovery was not of just one individual. Between 2002 and 2004, scientists found a total of 186 fossils from 30 different Titanoboa individuals, including 3 separately preserved skulls, a rarity for snake fossils. With an estimated length of 12.8 to 14.3 meters and a weight of over 1 ton, Titanoboa took the crown as the largest snake ever found and one of the top predators of its era. With a size equivalent to a modern school bus, Titanoboa replaced Gigantophis as the king of snakes of prehistory. Titanoboa's extraordinary size was no accident, but the direct result of unique environmental conditions of the Paleocene. As a cold-blooded reptile, Titanoboa relied entirely on environmental temperature to regulate its body heat and sustain metabolism. Scientific estimates suggest its habitat's average temperature ranged from 30 degrees Celsius to 34 degrees Celsius, 86 degrees Fahrenheit to 93 degrees Fahrenheit, much warmer than today. This supports the hypothesis that the hot, humid climate after the extinction of the dinosaurs created the perfect environment for giant reptiles to thrive. With a massive ecological void after predatory dinosaurs vanished, Titanoboa quickly rose to claim the apex predator role. The clear link between temperature and its size shows the deep dependence of cold-blooded animals on climate, and indirectly explains why no snakes today reach such sizes. Our global climate has cooled significantly. Size and evolutionary fate. The fossils of prehistoric giant snakes tell not only of incredible monsters, but also provide insight into the forces that shaped life on Earth. Gigantic size, as the script suggests, was a double-edged sword in evolution. While large size made these snakes apex predators, without direct rivals, it also came with inherent risks and weaknesses. One of the greatest weaknesses of giant size in cold-blooded animals is complete dependence on climate. The larger the size, the higher the need for warm environmental temperatures to sustain metabolism. Titanoboa, for example, required an average temperature of 30 to 34 degrees Celsius to survive and grow to its gigantic size. Similarly, Vasuki lived in a tropical environment with an average temperature of around 28 degrees Celsius. This made them extremely sensitive to even small climate changes. Their fate was sealed by a global cooling event at the end of the Eocene, called the Eocene-Oligocene transition, EOT, or the Grand Coupure, about 33.9 to 33.4 million years ago. This event caused the extinction of many large animals that had thrived in the warm Eocene climate, including these giant snakes. It was also the time when the Indian subcontinent collided with Asia, creating the Himalayas, a geological event of great significance for animal migrations. The EOT was a major geological turning point, marking the shift from a greenhouse world with no ice to an icehouse world with the first large ice sheets in Antarctica. The main cause was believed to be a drop in atmospheric carbon dioxide, CO2, below a critical threshold, allowing the rapid formation of a permanent ice cap on the Antarctic continent. This event caused the extinction of many large animals that had thrived in the warm Eocene, including the giant snakes. In Europe, this event is called the Grande Coupure, meaning the Great Cut, because it caused a sudden and profound shift in terrestrial fauna. Europe's endemic mammals disappeared, replaced by a wave of immigrants from Asia, including ancestors of modern rodents and ungulates. This change was driven by climate change and falling sea levels, exposing land bridges that allowed Asian animals to migrate westward. While the event had a major impact on European ecosystems, studies also show that the EOT caused significant cooling, about 4 to 6 degrees Celsius, at high latitudes, while the effect in the tropics was more modest. It was also the time when India's collision with Asia created the Himalayas, influencing animal migrations. Moreover, gigantic size affected how they hunted. Instead of chasing prey, these predators mainly used ambush strategies, waiting and striking with crushing constriction. Snake constriction is a far more complex and precise mechanism than commonly thought. Contrary to the belief that snakes crush bones, research shows their constriction actually stops blood circulation, preventing oxygen from reaching vital organs like the heart and brain. This causes unconsciousness in seconds and cardiac arrest shortly thereafter. The continuous discovery of new fossils, like Vasuki indicus recently, is living proof that our knowledge of snake history and evolution is constantly being updated and reshaped. These findings not only fill gaps in the fossil record but also challenge long-held hypotheses, forcing us to reconsider the connections between biology, geology, and climate. In the end, the fact that prehistoric kings like Titanoboa and Vasuki no longer exist today shows the fragility of gigantism in a changing world. After millions of years of dominance, they became bones and stone, reminding us of nature's power and that every evolutionary pinnacle has its limit. Perhaps we have only scratched the surface. Nature still hides many miracles beyond even the idea of immortality. So which survival manual would you choose to live healthier? The flexibility of cyanobacteria, the resilience of trilobites, or the sharp instincts of Anomalocaris? Would you be willing to live another 100 years if it meant sacrificing present comforts like strict diets or harsh environments? Leave your comment below and don't forget to like, share, and subscribe so we can keep exploring prehistoric stories together. See you on the next adventure.